Hello, I'm Jesse, I'm on the far right, and from right to left we have Kevin, David, Alan, and Andrew. We're Group 37 and our project is on an autonomous vehicle with parking assist. Almost half of people will drive further to avoid parallel parking. 15% won't park at all and they'll just go home. Current systems are expensive and unreliable, so our goal was to create a control system for an autonomous vehicle that could accomplish this for a low cost. Before we installed any of the control systems, we simulated the parking maneuver using the Unity video game development engine. This platform is often used for artificial intelligence or autonomous vehicle research, so this was perfect for us. The first step was to have the car find a place to park. It knows it's done this when the front right and the rear right sensors detect something, but the middle sensor does not. At this point, it continues forward until the middle sensor and the rear right sensor detect an obstacle, so it knows where the back end of the front car is. From there, it starts the programmatic S-turn to complete the parking maneuver. When that's finished, it uses the difference between the front and the rear sensor to center itself in the space.
Brakes for the autonomous vehicle are controlled by an actuator which is connected to an H-bridge and an Arduino controller. The H-bridge allows us to reverse the current through the motor, thereby allowing the actuator to engage and disengage the brake. The Arduino controller allows for speed regulation, and we can control the timing of the brakes through the use of an onboard computer. As a safety measure, instead of going with a steel ring, we went with a zip tie, as that would break before the floor.
In this section, we will discuss the steering mechanism. This mechanism went through 4 different iterations. The chain-driven steering motor is capable of providing 27.2 Nm of torque to the steering column, and when coupled with the larger sprocket is more than sufficient to turn the steering wheel. A rotary encoder will provide reference for the vehicle's steering position. In this video, we see the sprocket, chain, and motor working together to turn the steering column. As seen, there is additional strengthening braces added to the system so it will not flex when the motor applies a torque.
Our car's autonomous acceleration system consists of 2 main modules, an acceleration module and a direction control module. The modules are connected to the existing circuitry using mechanical relays so the system can switch between manual and autonomous mode. When the relays are turned on, the autonomous mode disables and bypasses the manual controls.
The autonomous acceleration controller works by using 2 digital potentiometers to mimic the car's acceleration pedal potentiometer. At rest, one digital potentiometer is set to low and the other is set to high. To simulate the pedal being pressed, one digital potentiometer's resistance increases while the other one decreases. The capacitive touch module is used as an emergency turn-off switch for the autonomous mode. It works by using an Arduino to send a signal from one pin to another through a resistor. Then into the receiving pin, a wire is run to some metal tape on the steering wheel. When the metal tape is touched, the capacitance of the circuit changes, and the Arduino can detect that change as seen in the spike on the Figure 1 graph. This is used to disable the autonomous braking, steering, and acceleration as a fail-safe switch to revert back to manual control.
There are 5 ultrasonic sensors used in this parking system. They are positioned so their field of view is maximized to see as many obstacles around the car as possible. Each sensor has an approximate detection distance of 1.75 meters. To summarize, we successfully retrofitted a vehicle with sensors, motors, and actuators. In doing so, we achieved level 2 autonomy by having control of the braking, steering, and acceleration. If work were to continue, we would add more sensors so that we could also have object avoidance. Unfortunately, the COVID-19 outbreak ended our project 3 weeks early, but this is where we ended up.
done!
Sorry, guys.